here also in case someone wants to be in contact with you with more questions. So again, thank you very much. And now let's move to our next speaker, who is Patryk Urban. I see you were here, Patryk. Can you hear me well?
Yes, I can hear you well. Can you hear me?
Oh, yeah, I can hear you. Fantastic. So I don't want to miss this one. So Patryk Urban is Business and Technology Development Manager at Inphotech. And he has a large experience in data communications, especially using optical fibers. And he's also the manager of one of the clusters, if I'm not wrong, for this matter over the north of Europe. So Patryk, I don't want to take more of your time. Think you can share your screen. If I
can you? It should be coming up soon. Can you see the screen?
Just one moment. Yeah, now I can.
Okay, I got the presenter mode.
Great.
Should be coming up soon. While it's coming up, let me say something first. Thank you for the introduction. First of all, thank you for the invitation. And just to add to that introduction a bit, it is the IEEE Photonics Poland that I'm managing, and I'm also a professor at the West Pomeranian University of Technology in Poland, in Szczecin. But here I'm representing solely Inphotech. So can you see the slides now?
I don't see them presenting. If you try to hit that button, now I see it in full screen. So all yours. Thanks, Patryk.
Okay. I would also like to thank all the speakers, the two speakers that spoke before me, because actually they set the ground perfectly for me. For all those applications that were discussed, you actually need a good wireline transport network. And here there is this big opportunity and chance for new fiber optic solutions. And this is what I'm going to talk about here. This is a bit daring title, perhaps, to say multi-core fiber is now closer to enter telecommunications market than ever. But I will actually try to convince you, and I hope to do that, that this is not a question. This is actually a statement. Before we go, let's the company that Inphotech, it's actually a group of companies, IPT Applied, IPT Plus, IPT Advanced, Safety, IPT Fiber. They are all involved in the fiber optic business and photonic business, and they are delivering products, solutions, and do quite intensive research for a variety of industry branches. And you see some of them here. Telecom being one of many, and telecom is the part that I develop and I present. Inphotech employs about 80 plus people these days, and it's been already a decade on the market, and it has quite a nice amount of granted patents. And it's quite a successful company. You see a number of awards and projects we've been involved so far, and yep, that's the word of introduction. And now let's get to the presentation. People tend to piggyback on the pandemic that we have nowadays and motivate their works, based on the COVID situation. I'll do it as well a bit, but I'll give you a different view on the problem. So you see those three graphs. What has happened in the network over the last year, say February to March? Okay, the initial period of the first wave of pandemic in Europe. You would see that you see traffic changes with blue curves, and the green curves, they represent download speed change in the network, and then the red curve is the actually case rate of COVID. So the pandemic countermeasures, so the social distance, remote working, home working, have caused internet usage to rise by 50% worldwide in general. Because we basically, as said, we turned from public to home entertainment and from office to remote work. And some of the countries did quite well with the traffic and with their networks there. Some got a bad hit. But in general, nobody has really reported any major issues with the network being overloaded over this already long time, say. So one could say, okay, what's wrong? Is everything fine? You know, we in the telecom business don't care about the COVID situation. Well, apparently, instead of enabling more transmission capacity that would be needed in areas where home office is promoted or being executed, bandwidth usage was limited by service providers. So in order to maintain the network up and operational, quality of service has been traded off for link availability. And as an example, we could say Netflix has lowered the quality of streaming. I think it has happened mid-quarter two, what they did, in order to still maintain the customer base, of course. Some e-government services failed to operate effectively. We could see, some e-administration issues in Poland and some other countries on the way. E-health, which could be actually really helping out in this current situation, is it's in infancy of operation. Only few countries could really benefit from the services. One side of it, of course, is the lack, perhaps, of developed services, e-services serving e-health. On the other hand, it is also the missing infrastructure that would be needed to do to run the e-health services. And I'm not talking only about the teleconferencing with the doctor, but health control, basically, health monitoring. Yeah, and exactly, mind the quarantine as the use case scenario. So, you know, people could be self-quarantined at home and being monitored remotely, provided, of course, infrastructure, telecom infrastructure, reliable telecom infrastructure is there. So for the future, we should be more proactive and not really reactive. And by that, I mean we should actually better prepare our networks for the rising data flood. And this is not only that, you know, we expect third, fourth, or fifth wave of COVID or anything alike, but actually some habits that we are, adjusting to these days will keep on even after the pandemic. We've seen a lot of I've done this survey actually with some major employers that they see great benefits in this current situation as they are reducing their costs, operational costs of their companies. People are based at home, so the less space in the office needs to be maintained. There is lower power consumption, and there is less traveling, and there is, we impact our environment, also natural environment, less with the combustion. And we could already write books about the benefits, if I may say so, of the pandemic. So actually, the telecom and the technologies that are to progress and evolve telecom area are being given a chance to help humanity. Now, this sounds like big words, but this is reality. So what we more focus on these days is rather the meaningful connectivity rather than the bandwidth, in your telecom network per se, so bit per second, but it is the meaningful connectivity where the wireline or the physical layer network layer bandwidth is just one of the building blocks. And this meaningful connectivity still drives development in those network layers. So now let me get really down to the essence of this talk. Spatial division multiplexing. Perhaps it's known to some of you. Spatial division multiplexing is, let me briefly explain to those that may not be aware of that. Spatial division multiplexing is something that is yet unexplored in the domain in the domain of multiplication of the capacity of the network. So we've seen in optics, to give an example, wavelength division multiplexing, already well known for decades. Time division multiplexing, that is actually coming from the copper side or the metallic cabling network. Then we have and more advanced multiplexing techniques, and this SDM, spatial division multiplexing, seems yet to be unexplored, and perhaps the last stop for capacity exhaustion in the network. So you could consider the fiber that is or cable that's fiber that's already well known for some years. It's called ribbon fiber, and we could consider this as an infant case of the SDM, because what it really is, it provides in one ribbon several parallel fiber optic channels for transmission. And it has its limitations. You cannot bend it easily. There are challenges in splicing it, but there are solutions already well known, well established for long about that. But this is like, you know, infant first step for the for SDM. The true SDM would be when you occupy the same space, the same footprint with your current fiber, with your current cable, but you just multiply its bandwidth. So actually you are very space efficient. And this is what can be done with so-called multi-core fiber, or the next generation fiber that supports SDM. And as Inphotech, we've been developing this for many years, and we are in a stage of commercialization of this fiber. And you could see here on the right-hand side a standard traditional fiber, symbolic graph, of course, with a core that supports standard multiplexing techniques earlier mentioned, like WDM, so wavelength domain. And then within the same diameter of the fiber, you could actually induce several of those cores, each one having the same multiplexing support as in this case. So we are really multiplying capacity of the fiber. So this really explains now the basic building block for true SDM. But where could that find its application? First of all, where capacity needs are high. So every network segment that needs to provide high capacity would require either more advanced modulation formats for optics, or you know, simply more cables, more fibers. But if you want to maintain the same footprint, this kind of fiber or this kind of fiber solutions would be very welcome. And this capacity needs will be actually induced by the 5G transport networks. So the networks that are to feed with data 5G antenna units or radio base stations as well. And anything what comes beyond 5G, so 6G, I already heard something about 7G. This bandwidth will just simply multiply. The radio bandwidth will multiply, and this will turn to high capacity demands on the wireline network as well. This fiber could also find its application where duct space is scarce. So you have a telecom duct in the ground, and you want to pull you want to provide yet another connection there for yet another operator to coexist in the same passive infrastructure. How do you do that? If you don't have the possibility to or space to blow yet another fiber, perhaps you could exchange the old fiber and blow in the multi-core fiber. Where OPEX is critical, where operational expenditures are critical. This fiber, well, if you look at the fiber on the right-hand side, this is really a photo of our fiber. You have 7 cores of those fibers, all surrounded with air holes, for yet another reason that I will explain you later. If your fiber breaks, or if your fiber cable breaks, and each fiber there has just a single core. You need to splice every single fiber individually. Here in this case, if this breaks, you just make one splice for this 7-channel fiber. That reduces time, that reduces cost. This is just one of the examples where OpEx could be reduced. Now, where business relies on dark fiber. A dark fiber is the case when you have an infrastructure operator that runs its business on leasing the dark fiber. And here is an opportunity actually to boost up its business. And a bit tricky, perhaps, or too scientific, but still very valuable use case for optical beamforming in 5G and beyond 5G, where parallel or differential delay in parallel channels is demanded to be minimum. And we talked more about this co-signed paper at OFC with ADVA earlier this year. I know the time is running. I still have about 5 minutes, but is it 5 minutes?
Sorry, Patryk, you have about 1-2 minutes.
All right. I'll then jump to a couple of slides further.
Thanks for the effort.
About the technicalities about the fiber. You can read more about in our white paper that is actually linked here. And I just wanted to say that the fiber is more than that the SDM is more than just a fiber. It's about active fibers to build your optical amplifiers. It's about specialty splitters to support your SDM-based access networks. It's about fan-in, fan-out components to address your individual devices, your individual cores with a standard single-mode fiber. We have all developed that, and we have it well established. This is about the fan. I will skip that one. The one on the right is really our product. And the future view, well, not to be, without any kind of proof what is happening, let's quickly look at the standardization for the special division multiplexing. Nothing becomes successful in the telecom business unless it's standardized when we talk about the infrastructure. And of course, the world of telecom and datacom has realized that, and they set up activities for standardization of the specialty fibers. That applies to International Telecommunication Union activities and IEC activities. And you will see initial technical reports and recommendations coming out in the coming years, in 2 years. I think that's the scale. In a couple of weeks, a workshop will be held at the European Conference on Optical Communications, where these people involved in standardization and representative of the industry and academia will talk about the technologies for next generation ultra high density cables, and it's about the new fibers and new cabling technologies. So the key takeaways, that brings me to the very last slide now. I would like that you take away the 3 messages here. Providing reliable connectivity is essential for further development of national economies and societies. And the COVID situations actually show that there is work to be done on network systems to prepare ourselves for the future. Fiber optic technologies, including multi-core fibers, are in spotlight as they are the building blocks for next generation communication networks. And industry is well aware of that. Standardization is ongoing and the field trials are taking place. There was a slide on field trials and lab trials that I just skipped for the matter of saving the time. I really hope I have convinced you that actually this is a statement and not a question, that the SDM/multi-core fibers is really closer to enter telecommunication market than ever. Thanks for your attention, and sorry for perhaps taking 1 extra minute.
Hi, Patryk. No, you've been fantastic in time. Thank you very much for the effort and for the talk. It's really interesting, and I think that it brings like a complementary view for communications where fibers are used. I have one question. I don't see any more questions here in the chat, but I've seen in scientific papers in general that people talk about spatial division multiplexing through one of the cores of the fiber. So in this case, you are considering that you have all your communication channels spatially divided, physically divided between each other, but it's also possible to have multiple, for instance, orthogonal modes, spatial modes across each of these on top of that, right?
Yes, you're right. And actually, it addresses this slide that I skipped for the sake of saving the time. Yes, we talked about, or I talked about the single mode multi-core fiber. But alternatively, you could run a few mode fiber where individual modes are the individual channels. But the drawback here is that you need quite a heavy digital signal processing on your receiving end to filter out crosstalk. And that's latency and signal latency that it is being induced, and that's power inefficiency, and it's simply expensive. The multi-core fiber with a single mode, as you see on the right-hand side that we also are developing, is readily available to plug and play in your network because it's fully compliant with the standard single mode fiber. It's actually better even in some of those parameters.
I see.
So I hope that answers it.
Yeah, no, definitely. So there is still scope for enhancing all this data bandwidth by just changing to multi-core fibers. Very interesting. So we are a bit short in time. Sorry, I see one question here before we finish. Carlos Alfredo asks, are the coupling effects of the IPT core fiber to a photonic device the same for each core as for coupling a single core fiber?
Okay. In between the multi-core fiber and the device you want to couple to, we have the fan component, fan in or fan out, right? So that allows you to address individual cores and single mode pictate connect your device. So what matters is the splice of fan to the multi-core fiber. Because our fan technology is a so the reflection parameters, insertion loss parameters on this junction point on the sides are really uniform. So in turn, you don't have uniformity on the I hope that answers the question of Mr. Carlos, I think.
Yeah. I think so. So I think it's very short time, but I think it was really interesting your talk and your point of view. I would suggest that you also leave Patryk your email here, and if you want to leave the link for the white paper that you showed on the presentation, so they can also access it easily. I think
yes. Yes, I will.
All the participants will be very interested. So thank you very much again, Patryk, for your talk.